I just want to welcome everybody to tonight's presentation. This is the fourth out of six creation care discussion series meetings that we've had. For those of you I haven't met, my name is Dave Wild, and I'm going to minimize that. I won't be able to see you, but I think you'll be able to see the screen a little bit better. So this series is being put on by St. Timothy's Episcopal Church Creation Care Task Force. And tonight's presentation is going to be on regenerative gardening. And we want to start out with a prayer. So, Almighty God, in giving us dominion over things on earth, you made us fellow workers in your creation. Give us wisdom and reference so to use the resources of nature, that no one may suffer from our abuse of them, and that generations yet to come may continue to praise you for your bounty. Through Jesus Christ our Lord. Amen. Mm. So tonight, our presentation is going to involve our guest speaker, who is Dr. Shajimas Paskadi. She goes by the nickname Mint. She'll be our first presenter. And then Jonathan Trail and I will both be presenting about our gardens here in the South Bay. And then we'll have plenty of time for questions and answers. I want to let you know that tonight's meeting is being recorded, and you'll have be able to have access to that later if there's information that you wish to reference. And if you have questions, you can submit them during the presentations via the chat. Or just save them towards the end, and we'll have plenty of time for Q&A at the end. So I just want to introduce the topic of regenerative gardening. More and more people are discovering that tending a garden and growing their own food is very satisfying, especially during this time where we all have to stay at home. It may not occur to them, though, that their gardening practices and plant or soil choices could make a significant impact to our environment and affect climate change. Regenerative agriculture is a system of farming principles and practices that seek to rehabilitate and enhance the entire ecosystem of the farm by placing an emphasis on soil health. Well, most of us don't live on a farm, so Dr. Shajimas Paskadi will share how regenerative agricultural practices can be applied to the suburban environment to improve soil quality, soil health, and crop yield, and to help address climate change. Dr. Paskadi has been a certified master gardener since 2015. Her education background is in agroecology, soil quality, and plant sciences from UC Santa Cruz. Prior to residing in Santa Clara, she was an adjunct faculty at Fresno State, conducting research in areas related to soil fertility, cover crops, and compost. Currently, she works for the Santa Clara Unified School District as a farm educator, teaching students about soil, plants, composting, pollinators, and nature. So we are very happy that we have Dr. Paskadi tonight to present to us. And so I'm going to stop sharing and let her start her presentation.
All right, well, thank you for having me, and let me start my presentation. All right, can everyone see my first slide? Mm-hmm. All right, thank you, and feel free to call me Mint. Yeah, that's my nickname, and I often go by Mint, you know, like they would call me Miss Mint. So, you know, thank you, Dave, for the nice introduction. So I'm, you know, and so the topic of my talk will be related to regenerative agriculture, and then, you know, like sort of, I would give you a lot of information about sort of soil biology, biochemistry, and then we can have a further discussion about how, as a home gardener, can be utilize some of those practices and be part of this movement. So I happen to be a volunteer for both programs. If some of you are not aware of our program, I'm going to spend a couple of slides just briefly mention about our program. And we are certified volunteer. So we're part of University of California Cooperative Extension. For Santa Clara County, the north from Palo Alto down into Gilroy area. So unfortunately, we have to cancel 2021 training plan as we under pandemic. So hopefully, I would encourage those of you that for the love of gardening and like to be part of our program and check us out. The next training would come again in 2023. So we give free advice, through hotline. You can call. Email would be the best way to contact us. You can take picture and email us, and we have the website that I would list it at the end. And if we do not share your email with any other people, so pretty much if you sign up to receive an email, you will receive once a month email, which is kind of a nice reminder about what's going to happen, and what could you get your garden prepared for, upcoming weather and the change of the season. We do have like demonstration garden and research garden that I would make a list at the end as well. That it would be good to go take a look, and you can get some idea for your garden and landscape design, etc. We have a few public events that unfortunately at this time it has to be paused due to pandemic. We offer a lot more Zoom talk through local libraries. So for your group, Mountain View Library, I believe there is a couple talks coming up. You can check out our website to see those talks. So like I mentioned, we have 2 events that we have very good support from community, and those are fall and spring garden market. So I believe some of you be able to visit for the previous year. So now it used to be by History San Jose. So since about 2 years ago, I believe we moved all the sale to the Marshall Cottle Park, which is South San Jose area. But again, this year, both spring and fall is canceled. So I will kind of give you the idea of why climate change and agriculture and gardening are sort of interrelated. So I will give you the background information about climate change, and then, greenhouse gases, some of those agricultural practices that, impact climate change, and then how regenerative agriculture played a role, in this practice, and then the recommendations at the end. So we have, some of the question, if you could save it for the end, that would be better, just for the time part. And then, so we leave a lot of more time at the end to discuss more about your question. So this is kind of a classic graphic, some of you might recognize this from some of the documentary and articles. So the way that, it's already proved, and we sort of, under this, with all this unusual weather that happening, the wildfires that, is more intense, a lot more this past couple of years. So the scientists, be able to record and study that, it's never, the carbon dioxide level in the atmosphere never been that high until this past 50 to, less than 100 years ago. So you can kind of see at the end that, for so many years, they be able to test it and see that it's under 300 ppm or part per million, but then the current level is rising rapidly, and it's already sort of like crossing 400 part per million. And just on a note, I have all the reference lists on the last slide. So if you like to go back and read more about it, that would be, you don't have to worry about taking note. So what are the greenhouse gas? There are several, we often hear about carbon dioxide, which is kind of sort of, we refer a lot about carbon dioxide because they are the #1 source of greenhouse gas, but there are other type of gas that, including methane, nitrous oxide, ozone, sulfur dioxide, carbon monoxide, and CFC, chlorofluorocarbon, which is like, we probably heard about, it used to be used in refrigerator and, those type of cooling, and it's no longer used. But again, for all those, even spray can and stuff, but because we use it at some point of time, so now they accumulate in the atmosphere. So where do greenhouse gas emission come from? So when you look at, I like this graphic that is sort of like, the bigger of this circle is a bigger contribution to the earth. So then, like a quarter of that came from electricity and heat, followed by 20% from agriculture and land, and then, industry, transportation, other type of energy use, food waste, and also building. So surprisingly, the cement that, like the construction also contribute to like carbon dioxide emission. So from this picture, when you look at it, as a human, we play a main role on, like with the rising population, there is a need of, having more food production to feed, the growing population. So then that's come to agriculture. But again, surprisingly, the food waste come down to almost 10% of this greenhouse gas emission. As a home gardener, one thing that we would encourage you guys would be, like to try to like, utilize those food waste instead of take it to the landfill, try to like compost it, either with, like hot compost or with the worm composting. So then that's how you're recycling the nutrient, including carbon, back to the soil. And I will discuss more in detail later. So this diagram is an overview of greenhouse gas emission in 2018. So as you can see that carbon dioxide dominate, the amount of greenhouse gas in the atmosphere, which is 80%, and then methane is 10%, nitrous oxide is 7%, and those fluorinated gas is about 3%. So how farms contribute to climate change? So agriculture today is responsible for nearly a quarter of the world greenhouse gas emissions. So that's how the previous slide show you. So I just like this diagram that, we're gonna look at it. So the different color represent, the purple one is nitrous oxide. The blue-gray color is carbon dioxide, and then the orange color is methane. So when you look from left to right of your screen, you can see that, methane and nitrous oxide came from, livestock management. And that's how, I would say that depends on how they manage the livestock production. It contributes to the amount of gas that released to the atmosphere. So that's include like manure management, and then, the gas that came from the cow itself. And then, the rice cultivation, which is, we do have those in, Sacramento Valley, but majority of the world do eat rice, and then, the energy, the big one that we can see, the soil management part. So primarily the fertilizer and the decomposition of organic matter from the soil. So soil body can be a big emission of carbon dioxide, but then it can be a good land use sink, which means that, if we be able to capture those carbon back, and store in this, we call soil carbon storage, So those depend on the practice. So that could balance that and, slow down the climate change impacts. And the land use and energy use on the farm also important, and also, like a majority part of the world, they still use that slash and burn, which is, the burning of the crop residue contribute to carbon dioxide in the atmosphere. So the use of nitrogen fertilizer, and for this picture, overall it's about synthetic nitrogen fertilizer. So the nitrogen fertilizer that came from the factory, the process of making nitrogen fertilizer itself does, contribute to more carbon dioxide and nitrous oxide. And then, the longer or the the long-term use of those nitrogen fertilizer on the farmland also, impact, microbial activities in the soil, and also, sort of not sustain the soil health in the way that if you look at the package, so like things that a lot of us probably familiar with Miracle-Gro, they have a high salt content. So the long-term accumulation on the soil, with those salt, it also impact microbes and the soil health for the long term. So the use of chemical fertilizer, one thing that you have to be aware of is that because it's so highly soluble, they can easily, going deep down and then, cause the nitrate leaching, which just means that it can collect in our groundwater. And then, it can be easily run off, with the storm and rain. And that's how, when they call dead zone in the Gulf of Mexico or other part of the world. So those, caused by the nitrogen that run off with the water and then collect in the ocean or lake, and then, cause algae bloom and the fish will die off. So this is kind of a nice picture that, people were wondering why the methane came out from livestock production. It turned out that, when the cow birth, they release that methane, like 95% of those from belching. And, it's related to how they digest their food. So the microbe in the cow stomach, break down those feed. And then that's how the methane emit from the livestock. So then the manure collection pond, the waste that came from the cow also release methane. So for the past 10, 15 years as well, the feedstock in the US, they try to capture those methane and be able to use it as a part of renewable energy, so because instead of get it released to the atmosphere and be part of this cost impact on as a greenhouse gas emission, they capture it and use it as an energy use. So this kind of related to our food choice, so in a way, there is a rising demand and, consumption for the part of the world that, they're not used to eat a lot of beef, but, with the wealth of people, they see that, consumption of beef is actually, sort of cause that high demand. And then that's why there is a increasing production of livestock. So this chart is about soil carbon storage capability that can help fight climate change. So I did touch briefly that, with the soil, when you look at it, so there are different farming techniques that can improve soil organic carbon storage. And then some of those techniques, we can apply to, as a home gardener, we can use it, So let's say that first one is called cover crop. So cover crop, you can think about that, for the land, if you let the soil follow, the soil is not protected by any vegetative. So if it has sort of storm and rain coming, it can run off, and the topsoil, pretty much 10 to 12 inch of soil are very important because that's where all the nutrient reservoir is. So growing cover crop during winter months are recommended, or during the time that you're not going to use that for consumption. So that's helped to enrich the soil. And then the crop rotation is important because you want to, every time you harvest, let's say that you grow broccoli, corn, so those are high nitrogen consumption crop. So when you remove that from the soil, make sure that you add replenish those soil with, compost or some type of nitrogen input from organic fertilizer. So then, you sustain the soil fertility. So a lot of the no-till farming has been taught more in California, even though it's been, very more like popular or used more in Midwestern of the US. So the less you plow the soil, so then the less carbon dioxide released from the soil. And then, you know, I mentioned how you apply compost and manure back to the soil to help improve soil organic matter and increase soil carbon. And agroforestry, you know, is kind of being part, is a part of agriculture in a way that, you know, so because when you think about, you know, like plywood or things that wood that we buy and use for construction and, you know, other things. So those came from the, you know, the plantation or the farming the tree. So that's important to think about, you know, when you grow trees and cut it down. So those trees, you know, that we use, you know, that's the tree can no longer capture the soil carbon. And I don't know, you can see on the bottom here. So the regions with highest potential to store carbon on cropland, you know, North America is #1, followed by Europe and South Africa and the other part of the world. So coming back, you know, just to sort of like, you know, they have shared with you that regenerative agriculture definition. So for this one, you know, it's a quote, I got it from the website that the publisher, the author of the Carbon Underground and Regenerative Agriculture Initiative. So it's this, he described farming and grazing practice that, among other benefits, reverse climate change by rebuilding soil organic matter and restoring degraded soil biodiversity. So pretty much, so that's the idea of, you know, like regenerative agriculture. And then specifically, the regenerative agriculture is a holistic land management practice that leverages the power of photosynthesis in plants to close down the carbon cycle and build soil health. You know, it crop resilience and nutrient density as well. So how that can improve soil health, you know, so you have to think about practice that increase soil organic matter. So what are soil organic matter? Surprisingly, you know, like for the soil component, soil organic matter is only less than 5%, especially in California, it's often less than 3%. The soil itself, you know, when we call soil as a sand, silt, clay, so those are mineral particles. So it's about 45% of the soil component. And as a farmer and gardener, you sort of manage the air and water component, which is sharing a quarter of those component. So when you think about, you know, like you can easily overwatering and cause the plant to be upset and, you know, die, or you can forgot to water and then, like, you know, with drought and other things, the plant also will not be that productive as well. But for organic matter, you know, 80% of organic matter are humus, with 10% of microorganism and roots, plant roots, you know. So the humus, you can think about it as a sort of like continuing decaying material. So the good example would be when you make compost. So compost will add, you know, humus back to the soil. So that's carb, you know, like adding soil carbon back to the soil, and soil carbon is a major part of the soil organic matter. So the agricultural practice that you know, recommend by you know, to pretty much restore the soil carbon, you know, the one that I mentioned briefly is a no-till or minimum tillage. So the tillage, you know, like you think about you know, like you do aerate the soil. Majority of California farmers think that it's still important to do that, but you know, like the recommendation is try to do it less and less, you know, because the more you break up the soil, you know, particle or soil aggregation, so then you know, adding oxygen to the soil, and then you sort of like stimulate microbial growth, and then it's actually release more carbon dioxide from the soil, which is we rather keep those carbon dioxide in the soil. So soil fertility is also, you know, increased in regenerative system biologically through application of cover crop rotation, compost, and animal manures. So the important part is to restore plant and soil microbiome to promote, you know, transfer and recycling of essential soil nutrients. So this is a good sort of like diagram to show you that, comparing organic fertilizer versus synthetic fertilizer. So you probably heard about term that organic farmers, they feed the soil to have a healthy plant. So the organic farmers, they do not feed the plant directly, which is what happened that when you add, chemical fertilizer to the soil, the plant would take up directly, but it's almost like you have, drinking too much coffee in a way that the plant would perk up, but it's not sustained in the soil medium. But organic fertilizer, you add that, to the soil, so then it's become part of the soil organic matter and soil nutrient. So those would sort of feed the microorganism in the soil, and then interaction to release the plant nutrient to the plant, and the soil carbon itself will store more in the soil. So there's two more practice that recommended. So how you building biological ecosystem diversity. So you begin with inoculation of soil with compost or compost extract, which can be compost tea. And then you restore soil microbial community population, structure and functionality that restoring soil system energy. So you can think about, like practice that, not only multiple cropping, intercropping, crop rotation, even native plants could be part of, excuse me. So they often recommend that to have hedgerow or, for border plant to, so that you have the flowering plant throughout the year, especially in your garden. It helps to attract pollinators. And for those of you that, often that you see a lot of flowers on your tomatoes or eggplant or pepper, but you don't get fruit, that could be part that you don't have enough pollinators in your garden to help making those fruit. So the area that, well-managed grazing practice stimulate improved plant growth and increase soil carbon deposit. And overall, pasture and grazing land productivity while greatly increase soil fertility, insect and plant biodiversity, and eventually, soil carbon sequestration, or pretty much storing carbon in the soil. So just like touch briefly, sort of like, what is photosynthesis and why carbon and carbon dioxide related to plant. So for plant itself, plant biology, when the photosynthesis is a process that sort of like how plant make food. So it's often happen with chlorophyll, which is the green green pigment on the leaf. So photosynthesis requires sunlight, so it will happen only during the day or with the sun. So plant will convert carbon dioxide to be part of their plant cell, and also like store in the root, and eventually like those it will end up in the soil because the root has like sort of, we call it carbon turnover. So there is a living root and the dead root. So then that's why it's important that, the bigger the plant, you have more root biomass. And so then photosynthesis start when the plant, start having leaves. So when, just carve to look at, this is sort of like the acorn that start germinate, and eventually it will become a tree. So there are a couple of headlines that were I just sort of found out during the research. Making this talk here that interestingly, Whole Food record that #1 food trend in 2020 is related to regenerative agriculture. And interestingly, they actually list the farm that practice regenerative agriculture, and they sell those products. And then there's a report about bee population recovering due to regenerative agriculture. So, how I mentioned earlier, it's about pollinating, and increasing production. And I think at the end, if we have time, we can actually watch there is the new documentary coming out. And it's gonna be, so this is a YouTube video that has a clip on it. We can watch at the end. I just don't want to, I have a few more minutes to finish my talk. So I mentioned earlier, this is, as a gardener, sometimes, it's nice to just go take a walk or have a tour so you can have this inspiration for your garden. So this is the the garden that part of we call demonstration garden that managed by volunteer from Master Gardener in Santa Clara County. So we have one in Sunnyvale, it's probably closer to Mountain View, and one in Palo Alto. There's one, a couple more in San Jose, and yeah, so that's the site. And for those of you that never heard about this program, there is a free native garden tour. So it's sort of the program that I did volunteer to this program once, that we encourage the gardener or home gardener to convert their landscape, pretty much their lawn, to be native garden. And after a few years, if they want to showcase their house, they open up for people to stop by. So it's required pre-registration, and it's always happen in spring. So check out that. And this is from one of the house near Campbell that I volunteered 2 years ago. So it's very beautiful. And for those of you that are interested to learn more about composting and how to make compost, there is a class that offered by Home Composting Education Program that under Santa Clara County as well. I help teach that class sometime. So you might be able to get, discount bin after taking the class, because different city has a different subsidized program. If you live in Cupertino, the bin will be delivered for free, but you're required to take the class. But for other part of the county, usually it's about half price. So you can pick either worm bin or regular, like big bin on the backyard. All right. Would be the end of my talk. Happy gardening, and this is kind of the reference that I mentioned.
Thank you, Mint. So, Jonathan, take it away and just let me know when you want me to advance the slide.
Okay, sure. Yeah. Hi, my name is Jonathan Trail. I'm a member of St. Timothy's Church. And thanks, Mint, for your presentation. It was great to see, and you'll see some recurring themes here too in my slides. But I've been living in Silicon Valley since 1997. I've worked in technology, but I've always had a vegetable garden at home. There's a picture here. I've got a few beds, and I grow mostly tomatoes, but also broccoli, cucumbers, peppers, potatoes, strawberries, zucchini, and some other things sometimes when I'm feeling adventurous, like pumpkins and watermelon. But my inspiration for sort of regenerative gardening came from reading The Omnivore's Dilemma a few years ago. I don't know if you've read that, but I highly recommend it. It's about sort of food and also industrial agriculture in the United States. And one of the examples that the author Michael Pollan talks about is a farm in Virginia called Polyface Farms. It's still in operation today. So Dave, if you go to the next slide, the founder of the farm, Joel Salatin, he's 62 now, but he's a self-professed, this is a quote from him, he's a Christian libertarian environmentalist, capitalist, lunatic farmer. So he's a little bit of a crazy guy, apparently. At least that's what people think about him. And he really started this farm to really build up this concept of sustainable agriculture and try to build a farm around natural sort of ecosystems and found in nature. So one of the things he did, which is a little bit interesting, is sort of thinking about not just farming in 3 dimensions, but also over time. So this fourth dimension of farming. And so moving crops and moving animals around the physical space over time really provides that sustainable sort of ecosystem. So one of the interesting things about this farm is it's quite productive, but he doesn't ship any products. You have to actually go there to get the products. He doesn't use any nitrogen fertilizer. And so you'll see some of the recurring themes from the nitrogen fertilizer comments that Mint gave. But I actually looked this up, and there is a small nitrogen fertilizer impact. Someone on the web did all their research, and they had actually discovered that he did buy some chicken feed that was used where nitrogen fertilizer may have been used to feed those chickens. So he doesn't actually buy any nitrogen fertilizer, but there could be a small impact there. So if you want to split hairs. But anyways, it's that inspired me to try to do some things at home. So if you go to the next slide, Dave, just thinking about how maybe doing something ourselves might have an impact on the climate. Some of these stats you just saw, but a chunk of all the fossil fuel emissions are due to production of food, and then of that, a bunch of that is transportation, and transportation just of food, and then people actually have now started measuring what the impact of your food transport is in terms of food miles. So if you buy canned tomatoes from Italy, for example, what's the carbon impact of transporting that food? Or if you buy, cucumbers or something from another country, what's the cost of that? So just thinking about, how do you transport food? There's a pretty wide range, but like anything that's air shipped is very, very high impact. So if you buy the fish imported from Japan, that's pretty expensive in terms of carbon. There's also, next slide, just again, some more numbers around the fertilizer. So one of the things that, the Min mentioned around nitrous oxide is actually N2O should be that first one. It's actually much more impactful than carbon dioxide. So just to note that I think your slides meant were normalized to the CO2 impact. So you saw that big purple arrow rising out of that one graphic. That was because nitrous oxide is 300 times more damaging than carbon dioxide. But anyway, if you could think about the emissions from crops in the U.S., and this is a few years ago now, it's basically equivalent to 41 million vehicles driving around every year. So that's it's a pretty big impact. So some of these principles we've already talked about can eliminate the use of nitrogen fertilizer. And so actually Mountain View, where I live, has a complimentary program for compost. It's something that we can all take advantage of, at least if we live in Mountain View. I'm sure other towns have that as well, where you can get free compost from the town. So in terms of some of the things that I've done, I'm just, I guess I would say, a beginner in terms of farming, but I started trying some of these principles out a few years ago. So I've actually started planting cover crops. Fava beans is my favorite one because you can actually eat them as well. There's other crops that I've tried, like buckwheat and some pea flowers, and there's like tons of cover crops you can buy that are beautiful. They flower, they attract pollinators. My favorite is fava beans because they grow like weeds, basically. This is not a picture of my garden, but my garden looks just like this in the wintertime. I basically just plant fava beans. They grow like weeds, and then you can eat the leaves for salad, so they're really delicious. They also provide the actual fava beans eventually, which I use. I grind them up with Parmesan and olive oil, and I spread them on bread, and they're just delicious and really healthy. Also, they are net nitrogen contributors to the soil. So that means that they produce and produce more nitrogen in the soil than they take out, essentially. So it's just, I highly recommend that. And again, they grow like weeds. We actually had fava beans sprouting in our front yard. We have no idea how the seeds got out there, but they grow all over the place. So next slide, I think, is some rotation. So again, these kind of different types of plants. The fava beans are legumes, but you can do that in the winter and then plant other things in the summertime. You can also do a rotation where you just have different vegetables growing all the time. My personal favorite is tomatoes, so that's like what I do most of, is just tomatoes. But there's lots of resources out there that allow you to have interesting crops all the time and still maintain that soil health. Next. So yeah, so this is just the result from this past couple of months. So far, and we're not done yet, we've gotten over 50 pounds of tomatoes, we think. We did a bunch of canning and canned them all up. I think I saved a few kilograms of carbon dioxide just for food transportation, because I don't have to go buy cans of tomatoes from the store. But just in general, they just taste way, way better anyway. And then, of course, the fava beans in local compost allows me to, avoid all that nitrous oxide emissions from the fertilizer. So I think that was all I had. Dave, you want to take it away?
Okay. All right. Thank you, Jonathan.
You're welcome.
So I've loved gardening for a long time. I think my mom showed me how to properly trim a crabapple tree in their backyard, and that got me hooked. So I've been doing yard work family. And got one of my first jobs was mowing lawns. Spent many hours in other people's yards. Had two major home re-landscape projects over the years. And it was only recently that I got serious about growing our own food. And I say our because my wife Ann and I have really enjoyed doing that together. We've had vegetable gardens previously, but sort of did it half-heartedly and had results that reflected our effort. Recently I've been inspired to learn more as being part of the Creation Care Task Force at St. Tim's, and wanting to present on this topic. I started looking into these different sources of information. Biggest Little Farm is a really cool movie. It really showed me that it's more important for things to be healthy than to look pristine and well manicured. The urban homestead was really cool. It's a home in Pasadena where almost every square inch is covered with some kind of a crop in a pot. Good News Garden program is through the Episcopal Church, and they encourage people to create gardens and plant, pray, and proclaim. And part of that is sharing the bounty, God's bounty with other people, especially if you have a larger garden, perhaps at church. Climate Victory Gardens are encouraged through Green America, and reminds people about the Victory Gardens during World War II. And then I had seen a sign for a National Wildlife Foundation certified wildlife habitat, and looked into what was involved, and it requires that you provide food, water, cover or shelter, places to raise young, and incorporate sustainable practices. So I thought that was cool, and tried to include that in my my current yard and practices. So earlier this year, probably mid-June, got a crazy idea to expand our existing vegetable garden. The two raised beds in white that you see in the left photo, that was our vegetable garden, and wasn't a whole lot to it, but I thought if I could remove two cherry trees that were diseased and not really producing anything, and then enclose that space with a fence, I could expand my vegetable garden territory. So that's what I did, starting mid-June, and worked out pretty well. Knowing that healthy soil is really important, I put a lot of chicken manure and compost into the soil, both in the raised beds and the soil that I now enclosed into the front yard, and replanted the two raised beds. So the picture on the left shows that fence has been pushed out, and now that soil that where a cherry tree had been is now a vegetable garden, or vegetables in the ground. And when I registered my vegetable garden with the Good News Garden program, had to name it. So came up with a Wild Harvest Garden name, and you have to have fun with your gardens. So I made a little sign there out of old rusty shovels. Other aspects of this project involved planting additional fruits and vegetables in the front yard, where you see that bird bath, that was where a second cherry tree was. And next to that are some artichokes and blueberries, strawberries. And the flowers that you see there, I planted as companion plants. And won't go into a lot of details, but there's a lot of information available about the benefits of companion plants, where they either detract or they deter pests, or they attract pollinators, or there's some benefit to the crops that they're planted next to, in addition to just looking pretty. I had what I call a bird sanctuary in this area for some time, a bird bath and a feeder. And as part of this, I wanted to expand that. So I'm up to two houses, 2 baths, and about 7 feeders. And of course, not just birds come, but the squirrels. And if you've got crops nearby, which I do, you have to be okay with the creatures taking their part of the crop. And I still try to chase away squirrels as much as I can. I find it a fun challenge, but it's probably a losing proposition. Also, I started composting food scraps. I had a compost bin for many years. Again, half-heartedly tried to start that some time ago, but was not successful, so I abandoned it. But just a few weeks ago, we started our first batch, and I think the key is to make it easy. So we've got a little jar near the kitchen sink, and then when it's full, we take it out to the bin, which is right outside the side door. Makes it pretty easy to add food scraps to the compost bin. And there's a ton of information out there about how to do composting properly. You need a combination of different types of green waste in addition to the food scraps. So I'm still working on my first batch, but hopefully that will turn out well, and then I can add that to the soil. I've had Kilroy pest control come out for a number of years to spray for different pests, scales on a tulip tree, and I had apple trees with worms. This summer, at the same time I was working on this vegetable garden expansion, I instead of going to the default of spraying, I thought, what would be some natural solutions? So I saw that ladybugs or ladybird beetles love scales, and so I thought I'd give that a try and have fun, have a fun time activity for the neighborhood kids. And so there's recruited about 6 neighbor kids to help release hundreds of ladybugs that I got online into the tree. Did that twice because first time didn't work, second time didn't work. I don't know if the ladybugs were jet lagged or something else, but they just seemed to leave and didn't stick around to eat my plentiful scales. So now I'm trying some soapy water and scraping them off. And what you see on the left is actually what I'm seeing. It's really a nasty sight, and I got to do something that hopefully this next trick will work. I bought some codling moth traps, but it was too late in the season to stop the apples from being infected this year. So next year I'll get them out early enough to try to prevent that from happening. I have plentiful apples production, but almost every one of them has these lovely diseases in them. So instead of looking for the easy spray, I'm going to try to continue to look for more natural solutions. Upcoming projects include this fall, I'm going to try to create a butterfly sanctuary by replacing my side lawn in the parking strip with pollinator-friendly plants. And I know that monarchs are having a hard time of it, so I thought I would focus on plants that they especially like. I think milkweed is one of them. And then if I do that, I get to put up another sign in my yard, monarch waste stations. So how can that be been? And then also next year, investigate the use of gray water, which is water that comes from your home, your showers, laundry, see if that can be used to help water plants. Also collecting rainwater is a possibility. And I was inspired by Jonathan to do cover crops, and the fava beans seemed like a good idea to put nitrogen back into the soil. Some takeaways for me. Just on, I don't have a huge plot of land, but things that made sense for me was to focus on soil health. Previously, I would just dig a hole, put the plant in, and then expect it to do great things for me. And now I'm a little more savvy about helping to plant along with providing it with some healthy soil. Composting the food scraps, trying to reduce store-bought fertilizers and pesticides. There's a lot of home made recipes for these things. Mentioned companion plants. Love the idea of attracting pollinators, just because I have had very healthy looking fruit trees, but they're not producing fruit. So I'm hoping that attracting more pollinators to the yard will help produce more fruit. Reducing lawn and water use. Previously, I was very focused on the yard looking pristine, and now I'm getting more okay with letting organic matter stay where it falls, and leaves things where they can turn into humus that Mint was talking about is important to help organic matter get back into the soil. And one of the books I got had a scripture verse at each beginning of each chapter, and this one was one of my favorites, and it reminded me that you just got to try things. You may not always work the first time, but if you don't try it, you won't have much chance of success. So just try it out, and there's always next year to change your approach to things. I'll end my presentation with some gardening resources. Of course, there's the UC Master Gardeners website. 2 books that were just full of great information was the Suburban Microfarm and the Family Garden Plan. Way more information than I could incorporate into my small vegetable garden. Then I heard about the Plainsong Farm and Ministry through a Good News Garden online meeting, and it seemed like a pretty cool place, and it's something fun to check out there. Continue this Creation Care series in 2 weeks. The next topic is going to be reducing your carbon footprint, and Annette Trail will be leading that. Annette, did you want to say anything more?
No, this was an excellent kickoff to next week's meeting. We'll be drilling down a little bit more on methane, the effects of methane, and what choices we can make to reduce our carbon footprint.
Okay, great. And then 2 weeks after that will be a topic of environmental justice. So I hope that all of you can continue to participate and enjoy these discussions. Let's close with another prayer. We're called to be God's partners. Bountiful God, you call us to labor with you in tending the earth. Where we lack love, open our hearts to the world. Where we waste, give us discipline to conserve. Where we neglect, awaken our minds and wills to insight and care. May we, with all of your creatures, honor and serve you in all things, for you live and reign with Christ, Redeemer of all, and with your Holy Spirit, one God, now and forever. Amen.
Amen.